Well, I think people are still coming into the meeting, but just as people are joining us, and we've got many attending, let me welcome all of you to this seminar from the UCL Institute of Sustainable Resources, where we will be addressing the topic Decarbonising European Industry and Steel in the Global Context. And this seminar, this webinar, is partly drawing upon and will help to present some recent research supported from the INNOPATHS Pan-European programme. And we will be covering in the first half those broader analyses of the challenges of decarbonising industry. And in the second half, zeroing in on the challenges, particularly for the steel sector, obviously one of the biggest industrial emitters, one of the highest values, and a topic of considerable interest right across the UK, Europe, and globally. And we're going to take the first half hour with a scene setter about a recent development, actually after we'd already started to organise this meeting, which was the launch of a new initiative by the Clean Energy Ministerial. So for the first speaker, I'll introduce speakers as they come to address us. So we're going to start with Dan Dorner, who is head of the Clean Energy Ministerial Secretariat, a team based in Paris. Fairly recent arrival there. You must have had a busy start to your first year there, Dan. Prior to that, he was head of the International Energy at BEIS, the UK Department for Business, Energy and Industrial Strategy. He's got a fantastic background for this, representing the UK at a whole range of international energy meetings, obviously including G7, G20, and many others. Prior to that, Dan worked at the International Energy Agency and has been lead author for its World Energy Outlook, has been a Sherpa with the United Nations. And so it's hard to think of anyone, but Dan, we are looking for anyone better suited to tell us about the recent developments, including the launch of the new programme on precisely the topic of this seminar. So Dan, could we hand over to you?
Brilliant, thank you, Michael. It's a pleasure. Let me just share my screen and make sure that it's all working okay. Has that come up? Can you see that okay?
That's fine.
Perfect, thank you. Look, hello everyone. It's a real pleasure to speak to you here today. And for anyone who may be feeling a little bit blurry after watching the England football match last night, I quite understand. But for the dedicated ones who've made it here, it's a real pleasure to be here with you. So I'll give a brief introduction to the Clean Energy Ministerial today, just for those who are not familiar with it, our work programme, and then give you much more detail about, as Michael said, the recently launched CEM workstream on industrial deep decarbonisation. This has just been launched by ministers and high-level stakeholders at our recent ministerial meeting, literally just a few weeks ago. And as I go through today, I'll try and give you a bit of a sense on the global policy perspective relating to industry as I've seen it over the last few months. So firstly, just a little bit about the Clean Energy Ministerial, or the CEM as it's most commonly referred to for short. And actually, in short, what is its purpose? Well, quite simply, the CEM is about international clean energy collaboration in action. It looks to bring together a combination of countries, companies, and international experts, all coming together in voluntary coalitions to work together to achieve one mission: accelerate clean energy transitions. And this slide just shows a bit of a flavour of who its member governments are, observer organisations, partner organisations. Also has a much longer list of other participants in various work streams. Again, it could be governments, subnational governments, companies, think tanks, academia. The list goes on and on. And the CEM and the work of the CEM, if you like, is kind of in three basic parts. So there's a secretariat that I run, an annual ministerial meeting, which is often the focal point for bringing together our community and our work and activities, and its work programme, which I'll come to in a second. And we've just had our 12th Clean Energy Ministerial meeting hosted by Chile. And this year, slightly different from previous years, a big outcome for us was actually about agreeing the future mandate of the CEM itself. And so it's really wonderful to have all of our members come together and renew and give us an ambitious new mandate, telling us that we needed to use all of our levers to help supercharge 3 key shifts in the clean energy landscape in the years ahead. They highlighted a shift in scale, the fact that the pace of clean energy deployment this decade must outpace the last decade, often by several times, a shift in scale of sectors, recognizing that while the power sector will remain critical to clean energy transitions, the focus must keep evolving from one sector to every sector of the economy and cross-sectoral integration of energy systems, and a shift in society, making sure that we have an inclusive whole of society approach, and that must emerge that looks across the role of governments and companies all the way through to the role of consumers and citizens. And they also confirmed that our next ministerial meeting in 2022 will be hosted by Secretary Granholm of the United States, and the one after that, CEM 14 in 2023, will be hosted by India and Minister Singh. And they're looking to co-locate it alongside their G20 presidency. So just a little bit more on what the CEM work stream looks like. So at the minute, we've got around 20 active work streams spread across the clean energy spectrum, as I say, across all different sectors, cross-sectoral integration, and across relevant enabling environment issues as well. And it's continually evolving. And at our most recent ministerial, we launched 3 new work streams. The most important one for here today is the Industrial Deep Decarbonisation Initiative, shown here. We also launched a new campaign on bioenergy and the substitution of bio-based products for, in the supply of currently fossil fuel-based products. And we also launched a new Empowering People initiative, looking at skills and inclusivity to build the clean energy workforce that we need for the future. There are also many deliverables under existing initiatives. For example, under our hydrogen initiative, which has proven hugely popular and successful, there was the launch of a global hydrogen ports coalition with around 50 ports and port companies from around the globe, which again is very relevant to the topic of industrial decarbonisation and thinking around the clustering of industrial and economic activities and looking at how they can potentially work together. So that's a little bit about the CEM. Now moving specifically on to why the CEM has moved into working on industry, what the case was that was made for our community, for our ministers and members. And I think we start, this is a familiar chart for those people who know the IEA Net Zero report that came out earlier this year. We kind of started with a view and a pitch that we put to our members that said, we really can no longer equate what has traditionally been the term hard to abate with the perception that in some way that means that it's the last one to tackle. We'll put off the hard job until tomorrow. We'll do the relatively easier things today. And as we can see from the work from IEA colleagues, and as I'm sure many people here today know well, industrial emissions are comparable to transport today, and they really can't be an afterthought when they're that significant in the decarbonisation that we're looking to achieve. And the great majority accounted for some key sectors like iron and steel, cement, etc. And the urgency of climate action encapsulated so clearly in a net zero by 2050 framing really does not allow us or afford us the luxury of sequential thinking. We can no longer think, oh, well, we're just going to decarbonise power first, then we'll think about road transport, then we'll think about appliances, buildings, and so on. But it means that we need to think about these things in parallel, and we need to really be in a hurry. And especially in those areas where maybe we don't have a fully kind of proven or known solution set in terms of technologies, or we really need to get the cost and the economics of those technologies down very, very rapidly. So really think about those areas where the gap between kind of current cost and economic competitiveness is maybe the most significant. Also thinking about those areas where the risk of infrastructure lock-in is the greatest. And again, drawing on IEA analysis, you can imagine a lot of these heavy industries, the assets are long-lived, highly capital intensive. And we can see that many of the industrial assets existing today, let alone being built today, have an expected technical or economic life that takes them to mid-century. Meaning again that it's an imperative now, not 20 years from now, which if you look back just a couple of years, people were often thinking, well, this is an issue I don't need to think about right now. I'll think about that in the 2030s or even the 2040s. But also just touch on here, when you're thinking about the transition of this infrastructure, of this capital stock, I mean, the other thing that's very, very clear, a huge amount of it is in emerging and rapidly industrializing developing economies. So you really need to think about the role that they play, working with them, how you transition that stock. And also just to touch on the fact that the socio-economic aspect of this and in these sectors is sometimes underestimated in both the discussion and in the metrics as well. So we need to think about not just the assets, but the workforces. Often these are very concentrated employment pools where a lot of people in a community are working with this within this industrial base, and we need to think about how in the case of that kind of concentrated source of employment in locations, how we think about that in the decarbonisation transition. And there's also no one path to net zero. I don't think that'll surprise anyone. Net zero commitments, I think, have been a very important factor in terms of really focusing minds on industry, recognizing that there's nowhere to hide. We need to be thinking about these things that we were kind of putting off until tomorrow. But in terms of the solution set, there's no one path for net zero for industry, and we need to recognize that. And in the scenarios taken here from the IEA's Energy Technologies Perspectives report last year, the range of solutions is quite different in different industrial sectors, and it becomes quite clear when you look at these charts. It's also clear that a number of these solutions are not, and potentially not, ready to be rolled out at the scale that is yet required, and also that avoided demand and materials efficiency is still critical in near-term thinking in particular, as some solutions need time to mature. And I think these charts just kind of map that in terms of the relative maturity, and think about, well, which are the things that we should be thinking about deploying as quickly as possible, which are those things that we need to make sure move very quickly from the early demonstration or early adoption phase into mass scale adoption very, very quickly. And the final point I'd make here is the prevalence of solutions that have in some way cross-sectoral application. So the use of clean hydrogen, CCUS, bioenergy, potentially have applications across sectors, and thinking about it in a holistic sense, either in terms of industrial clusters, hydrogen valleys, hydrogen ports and hubs, net zero cities. Having that integrating strategies and plans across sectors is really important when we're thinking about how to try and speed up the transition in industry and how it works with others. So the time for great action on industry is unquestionably now. The IEA and others have mapped out the policy pathways for achieving it, but there's still a lot to be done in terms of acting upon it. And in doing so, it's also a case that many of these policy prescriptions would benefit from some form of multilateral coordination and collaboration. And obviously that's where we and others come in. They would also, as I said, benefit from cross-sectoral thinking, which is another thing that we're able to do with our community. And so this is kind of, like one other example by definition is just, these are obviously some of the big consumers of energy, and their path from all the way through the supply chain, all the way through to the end consumption point. It's really important to be thinking about that whole journey and mapping that whole journey and thinking about where the opportunities are to reduce or fully decarbonize at different parts of that journey. And in scoping our initiative on industry, we obviously wanted to look at the existing landscape for international collaboration, make sure that we weren't duplicating, not trying to solve a problem that's already being solved, but if there were opportunities to do something that was in some way kind of positive and reinforcing and filling a gap that needed to be filled, then we could step in to help with our government-led platform. And so we need to both scale up domestic and international efforts, private sector and public sector. And as I say, there are several existing and emerging multilateral initiatives, some focused on the private sector, such as maybe Lead It or Mission Possible Partnership, and then others coming in focused on building the evidence base or mapping the pathways, some on proving prototypes and demonstration. But they're all pretty new, I would say. And, you know, as well as being relatively new, if I'm honest, most of them are also still relatively small. We're all talking to each other and all trying to ensure that we complement and amplify one another's efforts and not duplicate them, as I say. And there are quite literally on this chart several pieces to the puzzle, and they're generally pretty complementary. It creates a coordination challenge, no doubt, but certainly in all of our interactions with our other partners, and I'll come to them in a minute, it's clear that it's very manageable. And actually the aggregate is, you know, we need to see these initiatives scale very quickly, because speaking candidly, my biggest concern at this stage in terms of international collaboration on decarbonising industry is that while there may be several activities underway, they're not yet at the scale that we need to see. And I don't think that's a great surprise. And we need to make sure that actually, rather than proliferating new things, we need to scale the things that we've got and make sure that they all work effectively together if we want to get on a path for net zero. It's good to see overall activities in heavy industry are speeding up quickly, but as I say, it still feels to me in most cases they're still pretty early stage and need to scale. So then moving to the CEPS Industrial Deep Decarbonisation Initiative, which, as Michael said, was launched just a few weeks ago, actually. The overarching objective of the CEPS initiative is hopefully kind of simple and obvious. So it's about really kind of rapid acceleration of actions to decarbonise energy intensive industries. In terms of products, the initiative will focus initially on steel. And as a body, as a CEPS, is primarily focused on kind of the deployment end of the spectrum, trying to pull things into the market and get them to scale up. You know, the choice and the focus from our members around here is really about how do we create the demand environment to pull these products through into the market and help them scale up and commercialize. So it's really about actions to drive up demand for these products first and foremost, as part of the broader goal of market creation and in parallel, hopefully, cost reduction as that market grows. And of course, these are all global products. Global coordination and learning is required. Very conscious of trying to avoid the first mover disadvantage in this space. And therefore, kind of building regional and global scale demand, very much seen in our community as being to the benefit of all. Justifying the investment in the first place and getting the cost down for everyone. And in terms of the membership of the initiative, these things within the Clean Energy Ministerial, they evolve almost daily, it seems. So this picture changes quite quickly. So in terms of our leadership group, our co-leads, we have India, the government of India and the government of the UK. And we've got early participating members being Germany, Canada, and the United Arab Emirates. But a number of the other countries who are shown here on this slide, I expect to join over the course of the next couple of months. And I think it'll end up being a really strong coalition from both the government side, but also not shown here, government and industry participants themselves, think tanks and international organizations who I'll come to in just a second as well. And what we're often really trying to think about is, if we were to start with a blank sheet of paper on the issue that we're trying to solve and advance, what would be the dream team that we would like to see there? And you can imagine here, we've got some of the most kind of forward-leaning in terms of those people are already taking a lot of action in this area, but we've also got some of the really big consumers of these industrial products as well to make sure that that side is kind of factored in. More broadly, in terms of the collaboration and also linking back to the jigsaw that I showed, a number of other partners and collaborators coming in. The CEM, by its very DNA, has a very inclusive approach. Our natural instinct is to bring people into our collaborative platforms. And we've already seen we've got both UNIDO as the operating agent, the leadership group for industry transition, Mission Possible Partnership, IRENA, the IEA, and more already engaging in the work of this initiative. So it's looking like it's going to be a very strong group of collaborators and partners to take the work forward. Now, if I just delve in a bit more depth into what are actually going to be the activities and outcomes of this initiative, what is this action coalition going to look to achieve? Well, two broad goals, if you like. I would say the first one is very much focused on sourcing and sharing common data, common standards, trying to get commonality of targets, coordination and collaboration on that front. So kind of broad terms, collaborative platform, from the data all the way through to the targets, all the way through to the action. And the second very much being the focus on encouraging governments and the private sector to buy low carbon steel and cement. So very much trying to build the demand for the products to try and help build the market. Underpinning those two things, several areas of focus and key activities, because making these goals a reality requires a number of complementary efforts and outputs, all over the course of a 3-year initial timeframe, I should say. So looking at development or adoption of a standard environmental reporting mechanism for both the cement and steel industry, providing a consistent communication framework for organizational accountability, a standard evaluation process and tools for project bids which incentivize and reward public work contractors on their commitment to source decarbonized building materials, consistent minimum standards for low carbon steel and cement. There's already been quite a lot of work done in this area. Look to see that proliferated and adopted. So standards for low carbon steel and cement products to encourage best production and manufacturing practice, procurement guidelines for government agencies detailing how to set out environmental project targets and incentivize contractors to source and use these low carbon products. The launch of a free or at least very low cost certification service, recognizing the value that that might be able to play. Publicly available data, research and tools for industry and governments to help them set their targets, establish industry-wide definitions of key sustainable products, improve production processes and benchmarks. Industrial deep decarbonisation training and knowledge sharing to ensure that all cement and steel manufacturers have access to the information required to participate in this global race to net zero. And overall, global 2050 vision for the decarbonisation of steel and cement industries with ambitious targets informed by our stakeholders. Feels like quite a lot to do in a 3-year period, but I should also say that SEM initiatives always evolve very quickly. So I'm sure this will just be our starting point and more things will crop up as we go along. Just to highlight in terms of early action within the initiative. So in addition to establishing and building the initiative and the specific near-term focus is also on the development and launch of a green procurement campaign. So really trying to get the issue of green public procurement raised up the political agenda, raised across the government spectrum, trying to get awareness and try and get signatories to that campaign to make commitments to build some momentum. We're looking to leverage the purchasing power that governments at different levels have, and members are envisioning public and subsequently private procurement to drive demand and create that market pull for these low emission products. So we're looking to make the most of the SEM's member country network, and this initiative is advocating for governments to set procurement targets for the purchasing of decarbonised steel and cement. Now, the campaign is envisaged to be launched at COP26 later this year, and the target that has been set by the governments participating is that within these 3 years, they want the initiative to have encouraged at least 10 governments to make public procurement commitments for low carbon steel and cement. An estimated 80% of cement and 90% of steel is produced in around 10 countries respectively. So, and they all fit within the SEM's membership. So actually, if we can even just get those or most of those, that will make a big, big difference in terms of the global picture. And we've already done a bit of work around the Green Public Procurement campaign. Some early work on the role of Green Public Procurement has been undertaken and published to inform this upcoming campaign. It was released at our SEM 12 Ministerial meeting and highlighted 7 important steps which will inform both the campaign and the initiative going forward. And as I said earlier, one of the great things about these SEM work streams is that they're very flexible, and so I expect that actually what I've outlined today will form the basis of the SEM's work on industry. that the CEPS work on industry will evolve quickly over time, which it actually absolutely can do within our structures. One example of that potentially going forward is by partnering with some of our other work streams and communities, such as on clean hydrogen, such as on CCUS, etc. So just in closing, so we need to have seen, in my view, the last of the typical route to industrial development. We need to see a clean industrial revolution, not as an afterthought, but very much as a first thought. I think there is, from the experience I've seen of the last 12 months, such as in the G7, for example, a real step change in the political and policy attention given to industrial decarbonisation. I'm no longer being viewed as something for tomorrow. But this, the actions that brings with it, it means that we really need to still move very rapidly from where we are today, from demonstration, get as quickly as we possibly can from demonstration to niche to massive scale. And I think some of the things that will help us do that is thinking holistically in terms of the solutions, the geographies, the public-private collaboration, thinking all the way across supply and demand. As I said earlier, no one solution fits all. Geographic clusters can be important in terms of facilitating industry's decarbonisation. Also, the role of emerging and rapidly industrialising economies is crucial. They're the big producers and consumption centres now and in the future in many cases. And I think when we look across global supply chains and demand vectors, let's also not forget about important things such as materials efficiency, advances in materials, process efficiency, just reducing demand, recycling, all of these other factors too can be really important, and we shouldn't forget about them. CEPS Industrial Deep Decarbonisation Initiative is very much focused on developing and delivering effective demand pull actions. As I said, a platform for international collaboration, for harmonisation of data, standards, sourcing and sharing of information, and collaboration and coordination across governments, across companies, across the whole heavy industry community. And we're really looking, first and foremost, encouraging governments and the private sector to start stimulating the demand for low carbon products, in particular steel and cement, and doing target setting and procurement policies and our green procurement public procurement campaign that really help supercharge that and initialize that. I'll stop there. Thanks for your attention. And of course, if you want to know more, please visit our website. But Michael, back to you. Thank you.
Well, that was great, Dan. Thank you very, very much. Clearly very timely that you could join us. I don't know if you are also tired after the England match. Thanks for but I think we have a pretty lively and sizable audience with us. And actually, one of the folks, one of the leading experts who'll be speaking later, has just sent a message to me in the chat. Who would like to raise one question for you. I think we've got a moment. I think we'll open up to wider Q&A later. I haven't seen ones coming in, but from Lars Nielsen, he's asked, how does the CEM initiative and the IDI initiative relate to the leadership group on industrial transition that I think you'll know, and also will heavy industry and steel become part of mission innovation itself? Obviously, to those of us slightly on the periphery, there's quite a range of activities, clearly CEM central, but could you maybe just address Lars's question there?
Yeah, absolutely. And it's a great question, and it links back to a point that I was making a bit earlier, but actually in the case of the leadership group, we're working together. So it's a recognition, they're looking to bring in on their side public-private partnerships around, in particular around demonstrators, trying to get in demonstration projects and trying to prove the different technological solutions and the routes to kind of getting through the market. On our side, we're really trying to bring through the demand pull side of the equation to try and make sure that the investors, the people who are looking at the demonstration opportunities can see that the market is going to be there. If you make it, if you invest in it, you build it, we will buy it. But it's very much a case that I'm really pleased to say, actually, that while there's a lot of initiatives going on, we're all working together and we're all trying to make sure that we're kind of contributing our piece of the overall pie.
And a follow on from Lars, actually, also, I'd be fascinated. Do you see this? Should it become part of the UNFCCC process? I mean, action on heavy industry directly?
Yeah, it's a good question. I mean, I have to say, overall, my kind of pragmatic approach to this whole thing is there is nowhere near enough action going on. So, and it links back a bit to the last point about the fact that there are, several initiatives underway, but they're just not the right, we're not yet of sufficient scale. We need these things to really proliferate very, very quickly. And I think that can also move into the international policy arena. That can also move into the UNFCCC arena. I think the more places I see activity in this respect, given where we are now, it's for the better. There may need to be some tidying up in future once things do really get the scale and we do see kind of what works and what doesn't work. But for now, I'd just like to see more activity everywhere, given how quickly we need to see things move.
Okay, that's great. That brings us bang on to 9:30. So thank you very, very much for that, Dan. And I hope the audience has found that fascinating, almost hot off the presses, so to speak. I gather you may be able to stay for some of the session today. So I hope you'll find things of interest and helpful to your mission there. Thanks again. That's great.
Thank you.
So I'd like to now move on to the next session, where we'll be hearing more about particularly the insights and findings from the UNNOPATHS programme. And first I would like to introduce, not that he needs much introduction for this meeting, Paul Ekins. He's of course Professor of Resources and Environmental Policy at our Institute Sustainable Resources, of which he was founder. And he's got an admirably brief CV given, but of course we all know it's an extraordinarily long one. But as part of his innumerable activities, whilst also running the Institute, he was a key person, one of the leads on the UNNOPATHS programme. Paul will just speak to us for a few minutes and then hand on for some of the technical results from that to Silvia. But Paul, over to you.
Well, thanks, Michael, for those words. And yes, it's a real pleasure to introduce the UNNOPATHS project to people. I'll share my screen. I've just got a couple of slides just to tell people a bit broadly about what this project was. It's a Horizon 2020 project funded by the European Commission. I'm the project coordinator overall. I'll just bring this up so that we can see. So we've got a number of national meetings going on. We've had our final conference. We're due to finish the project at the end of July, so it's coming up to its final stages now. As I say, a number of countries are having national meetings, and we've decided to have this one focusing really on industry. These are the partners that you can see there now. So you can see there's 15 of us spread around the European continent. And of course, that's been a great pleasure. The industrial work that I'm going to be presenting was done from Warsaw, Warsaw University of Technology, and indeed some of it at UCL later. And Silvia, who is going to speak immediately after this, is at PIC in Germany, so the Potsdam Institute for Klima. So this is the project overview. It's working with societal governmental actors to generate low carbon pathways for the EU. I'm not going to present any of the pathways that we've produced, but an important part of producing those pathways was to create new scenarios and to update the various modeling teams who are part of the consortium, not just PIC, but E3 modeling in Athens and CMCC in Italy. We want to understand the challenges of decarbonisation and then particularly the innovation needed to address them. So innovation was a fundamental theme of this entire project. Look at low carbon technologies in detail, and that was done by Aalto in the University of Aalto in Finland. And we've got an online tool called the Technology Matrix to look at policy and innovation system reforms that will help us meet greenhouse gas emission reduction targets. And the project started in 2016, which seems a long time ago now, well before net zero had been put in place either in the UK or at the European level. And what we now know is that the 2030 targets have been tightened up at both scales, and we've got net zero by 2050. The co-design process of these pathways was very important, working with various stakeholders. We were using a number of models to look at the social, economic and environmental dimensions of the transition. So what happens to employment? I was pleased that Dan Dorner mentioned that point. What's going to happen to the macroeconomy? And of course, looking also at not just carbon emission reduction, though that was central to the whole project, but a couple of, I think, really important papers on the co-benefits in terms of reduced air pollution. We've produced over 50 journal papers as a result of the project. You can find them all on the project website, INNOPATHS.eu. And I think that's all I need to say at this stage. I'll come back and present a few of the results from one of our case studies in a minute, but I'd like to hand over now to Silvia, who's going to talk about the electrification, particularly of heavy industry. She's a postdoctoral researcher specialized on decarbonisation strategies for energy-intensive industries. She's got a PhD in material science and engineering from University of Sheffield. So very nice that you came to the UK to do that, Silvia. Then worked as chief scientist for the development of new carbon capture and utilization technologies. And then in 2018, she joined the Global Energy Systems Modeling Group at PIC, the Potsdam Institute for Klima, one of Europe's premier research institutions, where she's focused on the analysis of the electrification potential in industry and in the energy transition at European and global level. So without further ado, Silvia, really looking forward to your presentation, and welcome to this meeting.
Well, thank you, Paul. Thank you for the nice introduction, and good morning, everyone. So I'm going to share my screen. Please let me know if you can see my slides. Do you see them?
Yes, we do.
Perfect. Okay, so yes, so as Paul said, I work at PIC, Potsdam Institute for Climate Impact Research, and where I look at industry decarbonization and electrification. And today in my presentation, I will try to provide an answer to this question. So we are on the edge of an electrification era. Is industry prepared?
You might just like to put your slides on full screen.
Yeah,
so.
they are, but I think you don't see them. So let me remove the second screen because I think that's the problem. You see them now in full presentation mode?
Yes, we do. So thank you.
Okay, perfect. Okay, so yes. So as I was saying, yeah, I will try to give an answer to this question. And so let me start saying why we talk about an electrification era. So of course, in this historical moment, we're observing a transition from a fossil fuels dominated world to a renewables driven world. And this energy transition is driven by is pushed by several drivers. And of course, there is an environmental component. So we know that electricity is easier and faster to decarbonize than on electric fuels. And if we look at the graph on the left of this slide, this is taken from the Net Zero by 2050 roadmap, recently released by the IEA. And it shows how the power sector would look like in a carbon neutral world by 2050. And we see that nearly 90% of the power supply will come from renewables, led by wind and solar PV. So obviously this roadmap places electrification at the center of the decarbonization strategies. And then there is, of course, another component, which is the economic advantage. So renewables are becoming increasingly cost competitive with fossil fuels. And indeed, in many countries, they already are. So the table on the right is also taken by the IEA roadmap, and it shows the levelized cost of energy for different electricity generation technologies in Europe in 2020 up to 2050. And we see how solar PV and wind are already indeed cost competitive with other electricity generation technologies. So obviously, if we put ourselves in or imagine ourselves in a world, carbon neutral world in 2050, where we have plenty of clean electricity available at a cost competitive price with other fuels, then we would have an energy market that is completely different than what we know today. And this transformation will have significant implications for all the end-use sectors, so transport, residential, and of course, industry. And in particular for industry, it's very important to make this consideration because of the nature of industrial infrastructures. Like Dan already spoke about it, so we know that industrial plants have very long lifetimes, from 20 up to 40 years. So obviously, all the investments we make today or we make tomorrow on industrial infrastructure will affect and will shape how we see industry in 2050. So these investments have the potential to jeopardize our capacity to meet this climate neutrality target, carbon neutrality target. And in general, going to electrification, we know that for residential and transport, I think it's well accepted that electrification will play a central role for the decarbonization of these sectors. Whereas for industry, we hear less about electrification, or at least there is less clarity about its real potential. So last year, with my team, we published a study where we looked at CO2 reduction potential for the European industry via direct electrification of its supply. And in this paper, we identified available electric technologies for industrial applications. We estimated the technical potential for electrification. We tried to quantify the energy savings and also estimated decarbonization potential. So now I will kind of go through the results of this paper. So we started by looking at the energy use in the European industry. We took into consideration 11 industry subsectors, which account more or less for 90% of the final energy demand and CO2 emissions from the European industry. As you can see from this bar chart, the energy use in industry is very diversified. So the yellow shaded area represents what is already electrified, what the share of useful energy demand that is already electrified, and this corresponds to around 19% of the useful energy demand. Then the blue and red shaded areas represents the thermal energy use in industry. And this represents around 45% of the useful energy demand. And we were able to split this energy into low, medium, and high temperature processes. And as you can see again from the colors, all industry, the different subsectors are very diversified in the way they use this thermal energy. And then finally, we go to the gray shaded area of this bar, which is this bar chart, which represents chemical feedstocks. So these are fossil fuels that are used not combusted to supply energy, but rather used to produce intermediate chemical products. And this represents a large share of useful energy demand, more or less 36%. And these are also the share of energy that we cannot directly substitute with electricity. So we cannot substitute these chemical feedstocks directly using electricity because, of course, they are raw products. So we need to produce synthetic hydrocarbons, for example. Okay, so after analyzing the energy use in industry, we try to identify the available electric technologies that we have today to electrify this sector. And in this table on the left, we classify these electric technologies, the most relevant ones, based on operating temperature, technological maturity, applications, and efficiency. As you can see, we have plenty of options to electrify industry, and they cover most of the temperature spectrum, which is relevant for industrial processes, so also very high temperature. These technologies are mostly already mature, fully developed, and available to be readily implemented in industry. What we found, though, is that industry normally does not opt for electrically powered technologies because electricity is much, much more expensive than, for example, gas. So on average in Europe, we have a price ratio of 3 to 1, so electricity costs more or less 3 times more than gas. So obviously, when when industry has to choose an energy carrier to power their large production volumes, so then they opt for gas rather than electricity. We also found that electrifying the industrial processes could lead to energy savings because electric power technologies are normally more efficient, or at least have comparable efficiencies. So in particular, in our study, we estimated that with a full electrification of industry, we could cut final energy demand by 20%. So yeah, so after having identified the available technologies, we try to sketch how the electrification of industry would happen. Because we, of course, don't expect electrification to happen overnight. This would be a slow or anyway complex transition. And so we try to kind of envision a progressive stages of electrification. And we summarize this in this plot, and now I will kind of explain how we did it. So we started, of course, for what is already, from understanding what is already electrified across the different subsectors, as you can see. And so this is represented by the yellow shaded area in this map, in this plot. And you see that the electrification level is very different depending on the industry subsector. But it's in total around 19% of the useful energy demand, so there is huge potential to electrify more. Then we try to identify the entry points for industry electrification. So if we had to start to electrify industry, what would be the low-hanging fruit? And this is represented here by what we call stage 1, and it's colored with this blue shaded area in the plot. And what is included in this stage 1 is basically technologies that are already fully developed. So we know that these technologies exist and industry is familiar with them. For example, heat pumps, electric boilers, mechanical vapor recompressor. And then we also identify processes that are operated in low and medium temperatures, so below 400 degrees, and processes that are common to all industry subsectors. So for example, steam generation, drying, space heating, all processes that are common to any industry sector. So we think that electrifying these processes could be easy due to a joint effort, basically. And then we also chose technologies based on the fact that they can be implemented in hybrid systems. Because we are aware that for industry, the first phase of this transition would be important to have a continuous production, so not having shutdown times, so ensuring that there is energy to fuel the processes. And this can be done, of course, at the beginning by having these hybrid technologies, for example, a gas and electric boiler, but also a gas boiler coupled with a heat pump, so that we can ensure that there is always energy supply and avoid risks due to price fluctuations that, of course, would put at risk the industrial production. So then we quantified the electrification potential in this stage, and we estimated that around 42% of the useful energy demand from industry could be electrified immediately with technologies that are fully developed. And we also, of course, this is considered chemical feedstocks, considering chemical feedstocks. But if we remove chemical feedstocks and we consider only thermal energy, we estimated that the potential could be 66% of the thermal energy demand from industry could be readily electrified. Then we tried to identify the subsequent stage, so stage 2. This is very similar to stage 1 in the sense that it is also based on technologies that are fully developed, like electric furnaces, kilns, electric glass meltings. The main difference with stage 1 here is that the processes involved or considering this stage are sector specific. So for example, if we want to electrify glass melting, the electrification of this process will only rely on the efforts and the technological upgrade of a single industry subsector. So of course, and a subsector that of course requires also different operating conditions depending on the glass product, for example. So much more complex, and we imagine more, this electrification would require a more substantial technological upgrade. We estimated that electrifying the processes in stage 2, we would reach a 50% of electrification of the useful energy demand in industry. And if we exclude feedstocks, more or less nearly 80% of the thermal energy demand from industry could be electrified with existing technologies. So we wouldn't need to consider technologies that don't exist or are not fully implementable. And then we move to stage 3, and this stage in studies represents the maximum potential for industry electrification and includes technologies that have higher uncertainty. So technologies that are still under research and development phase, or that have other potential barriers. In the case, and as you can see from the red shaded area of this plot, this involves the most energy intensive and CO2 intensive sectors, so chemical, cement, and steel. In the case of chemicals and cement, we have similar issues. So these technologies, for example, to electrify electricity crackers and reformers or electrify clinker production, they are still under a development phase. So they are not fully commercial, they're not fully scalable. So of course, there is more uncertainty here. In the case of steel, the problem is not the technological maturity, because here we are assuming a full substitution of primary steel with secondary steel production. And we know the secondary steel production is fully developed, and industry is very familiar with this process. The problem here is how much scrap do we have available, and scrap is already highly recycled. So can we really have enough scrap to produce to cover the full steel demand that we have today? So this is really the main obstacle here. And of course, we have to remind that this study is based on direct electrification. So we are not considering, for example, iron reduction with hydrogen, although this could be a way to electrify steel via indirect electrification. But this is not considered in this study. So anyway, the potential in this first stage would reach 60% of electrification, and if we exclude chemical feedstocks, nearly 100% of the thermal energy demand from industry could be electrified with technologies that are still under development. After this, we tried to estimate the decarbonization potential through electrification. So the question was really, can we actually cut emissions? And so in this plot on the left, you see the emissions from industry in 2015, divided into indirect, direct, and process emissions. And then we have the emissions in stage 1, stage 2, and stage 3 of electrification, depending on different carbon intensities of electricity. So we first considered the carbon intensity of electricity in 2015 in Europe, which was around 300 grams of CO2 per kilowatt hour electricity. And we see that actually electrifying stage 1 and stage 2 would cause an increase in emissions, because of course electricity has a higher carbon footprint than gas, for example. And in stage 3, though, we would observe a decrease in these emissions. And this is due to the fact that we have all those energy savings coming from offsetting primary steel production with secondary steel production. So in total, we would observe a decrease in emissions. Of course, so this is clear that we need electrification of industry needs to go together with decarbonization of the power supply. And so we tested what would happen if we had a lower carbon intensity of electricity in Europe. And we took the values from the IEA energy technology perspective for Europe in 2030 and 2050. This corresponds to 108 grams of CO2 per kilowatt hour and 12 grams of CO2 per kilowatt hour electricity. And we see that already by decarbonizing the power supply, we would see immediately a cut in emissions already in stage 1. So not the most advanced stage of electrification. And then if we progress, the best case scenario we can cut up to nearly 80% of the industrial CO2 emissions. And if you look at this bar here, you see that basically we are reducing the bottleneck of industrial decarbonization to process emissions. So those emissions that cannot be, of course, cut via electrification. So in conclusions, we kind of were able to identify barriers and enablers for a successful electrification of the industry sector. So it is necessary, in order to have an effective decarbonization of industry through electrification, it is a prerequisite is to decarbonize and expand the power supply. Because in our study, we estimated that a full electrification of industry would lead to 3 times more electricity demand from this sector. So of course, we need to improve distribution and transmission grid. We have to implement storage technologies, and we will need to face large upfront capital costs to have this disruptive transformation in the power sector. Industry will have to maximize demand flexibility and develop new smart approaches to peak load management. So we need storage technologies, we need to implement hybrid technologies, and increase on-site electricity generation to have greater autonomy and reduce the risk due to price volatility. We also found that in most European countries at the moment, powering industrial systems with electricity would lead to a significant increase of the production cost. So what we found from also consulting industry representatives is that industry is very reluctant to invest in electrification, because at the moment, electricity is simply not convenient to invest in electricity, considering the price ratio with fossil fuels. So it is important that from a policy perspective, we give a clear signal to industry by reducing electricity taxation and levies in order to create a cost competitive electricity, so to have electricity being cost competitive with other fuels. And of course, also to give a clear signal to industry by implementing a carbon price, so that this cost can be taken into consideration when industry plans their investments for the new infrastructures. That's it. Thank you very much for listening, and I hope this presentation was useful in some way. Thank you very much.
Well, thank you very much, Silvia, and a really fascinating presentation. And every time I see it, I learn something else. We've done lots of other work, obviously, about some of the other issues that Silvia mentioned to do with the decarbonisation of the power sector itself, of storage technologies, of grid reinforcement, and all those other things. And indeed on the carbon border adjustment mechanism, which is proposed by the European Commission actually to iron out some of those competitiveness issues to do with decarbonisation of industry. Okay, I'm going to go back to sharing my screen just to take you through a few more of the results from this project. So here we are, and so that's where we got to. And one of the tasks that we had was to do a number of case studies. We did case studies across 4 different countries that you can see there. We looked at some to do with the agricultural sector, so biochar and livestock diet. We did a case study on building envelopes for new buildings rather than retrofit. We looked in detail at solar PV and wind, electricity smart meters, and then we had some case studies on energy management. Very important aspect in energy intensive industries, obviously, is to optimize the use of energy of whatever kind. And then we looked at battery electric vehicles and transit. And I'm going to focus now really on energy management in the steel industry. And as I say, this was work done by Tadeusz Skoczkowski and colleagues at the Warsaw Institute of Technology. Across the case studies, we found, as Silvia's just said, cost is important in terms of innovation, which is pretty obvious. As Dan said, and as we found also in the other case study, several technological configurations for decarbonisation exist in most sectors. It requires the concerted action of a diversity of actors at multiple scales. And again, we saw that from the Clean Energy Ministerial presentation. It's really important to direct this innovation. Most innovation in the kind of pre-decarbonisation era was, the value system that was directed, it was simply a desire for profitability. And obviously you get a certain kind of innovation under those circumstances. If you're wanting decarbonisation, then you've got to have, that's got to be an absolutely core part of the value system that is playing into the innovation system. Very important role for Europe, as opposed to just national governments. And it was very clear in our case studies across these 4 countries that sometimes the European level played an enormously important part in stimulating innovation. And when it happens, many things just seem to fall into place. You've got different sets of actors, overlapping roles, authority pushing in the same direction. Important technology push, important, as Dan Dorner was saying, in terms of demand pull, and very important, obviously, the research and innovation sectors of the economies, both in the private sector and the public sector, et cetera, et cetera. So lots of really rich detail from these case studies. I'm now going to focus on steel and some stylized facts really about the steel industry. I mean, this is simply mind-boggling, this picture that shows that China produced 53% of the world's steel in 2019. I mean, there is no solution to the climate crisis without China, and that's emphasized very much by that figure. The European steel industry, as many of us will be aware, has had a rocky 20 or 30 years. And the UK in particular, the steel industry has declined substantially since about 1970. Economic output from the UK steel industry, there you can see, has fallen by nearly 60% in the 30 years since 1990, but it still accounts for 13.5% of greenhouse gas emissions from UK manufacturing and 2% of total greenhouse gas emissions. So it's still very much significant in that context. And politically, of course, it's important in that although it employs a tiny number of people compared to what it was, I mean, its employment has fallen by about 90% from the middle of the last century. It's still about 23,000 people, and they're very concentrated in certain parts of the country. So what did we learn in the case study that we did? And you can find all these case studies and indeed all the INNOPATHS deliverables on the website. As we know, there are two main routes to produce steel. There's the integrated route with blast furnaces and basic oxygen furnaces, and then there's the electric arc furnaces, which use scrap, as Silvia said, and they consume about 80% less energy. The deep decarbonisation of steel will require breakthrough technologies, and I think Lars is going to talk a little bit more about those later today. They've been amazingly successful in terms of reducing their specific energy consumption, that is the quantity of energy per ton of steel produced. And in Europe, it's among the lowest in the world. And therefore, it wouldn't make any sense at all for the EU to reduce its emissions by outsourcing steel making to other parts of the world, because that would simply increase global carbon emissions where that steel is being made less efficiently. So it's very important that the EU steel sector, for as long as we're going to continue to use steel, that we do make it. Very different steel industries throughout Europe. You can see that bottom bullet point there, that 80% of UK steel is made by blast furnaces, whereas 75% of Italian steel is made through the electric arc furnace. And the UK actually exports about 9 million tons of scrap iron every year to mainly European countries to make this. So rather busy slide here. I've tried to emphasize some of the points that that came out of the case study in terms of energy management. Energy costs are huge, and when you talk to the managers in these industries, they stress that they have had to, for competitiveness purposes, they've had to manage their energy and become as efficient as they can. But there is still further scope, even in Europe, for considerable increases in energy efficiency. But there are large existing capacities with high emission technologies and long investment cycles. So if we're going to use these more efficient technologies, we need to start now and to make sure that we put them in now, because again, as Dan was saying, these technologies have long lifetimes. There's lots of R&D going on, but most of it is focused on these breakthrough innovations that Lars is going to talk about, and there's much less work on these incremental energy management innovations, and we'll discuss a couple of those in a minute. They've got a well-functioning network of research and innovation with those various institutions that are listed there, but there's scope for further international collaboration and industry government cooperation. And again, that's obviously what the Clean Energy Ministerial is trying to achieve. There's a tension between cost cutting and investments in novel capacity. And that's an obvious competitiveness tension, and governments have got a crucial role to play to try to iron that out. And at the moment, there are insufficient targeted economic incentives for the implementation of some of these energy efficiency technologies. But it is a very innovative sector. The rate of innovation has increased in recent decades if we look at the number of patents, etc. So it's in pretty good shape. But obviously, as we know, there's global oversupply of steel, and so the industry faces lots of challenges. Just a few thoughts there about Italy. We looked at Italy and the UK in some detail. They've always put very high emphasis on energy efficiency. They've reduced their specific steel energy consumption. And obviously, this is at a much lower level because so much of their production of steel is through electric arc furnaces. There are various regulatory requirements for energy management. There's a national industry plan that supports private investment, and they're increasing public R&D resources substantially. The UK, I think, has been a bit slower in taking these things forward, but there was an industrial decarbonisation strategy published in March 2021. We've got 6 blast furnaces and on 2 sites, which are important. I think I said earlier that 80% of UK steel comes from the integrated route rather than electric arc furnaces. We could increase the number of arc furnaces with hydrogen replacing coal for the use in reduced iron, and obviously, if we were to use some of our scrap for those purposes rather than exporting it, that would help. And as Dan said, there's an absolutely crucial role for public procurement to support these green industrial products, not just in steel, but across the industry piece. And it's very interesting to see the political debate now around public procurement helping to drive these processes forward. And again, there are a couple of funds that are intended to help industry in general and the steel industry in particular to use energy more efficiently and to decarbonize more generally. There's a real challenge for increasing our electric arc furnaces in the UK. So if we look at these 2 pictures, you can see that not only have electricity prices increased substantially in the UK since 2007, which is the left-hand graph, but UK electricity prices are substantially above the average EU industrial electricity price there. And one of the reasons for this, which again is something that Silvia mentioned, is that for reasons best known only to themselves, the government, when it has been funding renewables and when it has been funding energy efficiency schemes of various kinds, has put the costs of those on electricity, not on gas, on electricity, which of course is very much a perverse thing to do if what you're trying to do is increase the use of electricity. So that removal of these various levies would seem to be a priority. As a result of that, of course, the government has had to compensate heavy industry for these high electricity costs. Otherwise, they would have been completely uncompetitive and would have gone out of business. So the second part of my presentation, just for the last 5 or so minutes, asked the question, okay, so we've got these new breakthrough technologies that Lars is going to tell us about. How long will it take for them to go to scale? And there was quite an influential paper by Kramer and Haig in 2009, where they basically said that for an energy technology to reach materiality, which is this white bar here between 10 to 6 and 10 to 7 terajoules per year, it needs about 30 years. And obviously 30 years is quite a long time. given that we're at 2020 and we want to get to net zero by 2050. So that again is a further reason for not leaving this to tomorrow, because you can't get up the deployment curve fast enough in order to get to net zero by 2050. And one of the pieces of work that we did, and this is my colleague Will McDowell at UCL with some others, was actually to have a look at various analyses of past technologies to see how quickly we might expect these new steel technologies to become significant. And there is this core periphery acceleration hypothesis here. And if we look at the left-hand picture, you can see that the duration of diffusion, which is called delta T, from going from 10% to 90% of a new technology. You can see that the early movers who are in the core, they take a certain amount of time. And in each case for these technologies, you can see that as the technology diffuses out to more countries, they take less time than the early movers in order to reach significant scale. And the question that Will and his colleagues were asking was, what's the evidence in steel technologies for this hypothesis? And you can see from the right-hand picture that actually there's not a lot of it. Each of these dots represents a country that introduced continuous casting of steel, which was a major innovation in the steel industry. And you can see that the early movers back in 1950s, 60s, it took 10 to 20 years for these guys to reach materiality from 10 to 90% of steel plants. And then the later arrivals in steel making, you can see it in many cases took them even much longer. So no evidence at all for that hypothesis in continuous casting. There is evidence in respect of other technologies. So if we look at wind on the left here, you can see that the early movers, it took about 25 years. So we're probably talking about Denmark and Germany there to get to materiality, whereas later countries were able to get to materiality much more quickly, down to about 5 years here for this country here. And less clear, but still apparent is that trend in regard to flue gas desulfurization. And that's particularly interesting because one of the ways in which the UK will need to decarbonize steel is to implement carbon capture and storage, because we've got all these blast furnaces. Obviously, that's much less relevant to a country like Italy, where it's mainly electric arc. But if we're going to keep blast furnaces and we're going to keep using them with steel, and you will have seen from an earlier slide that it's part of the UK strategy actually to fit some of these with CCS. Diffusion of continuous casting, if you plot logistic curves here for again the way these technologies were taken up, you can see there's no real evidence for acceleration. And if we look at a couple of the incremental steel efficiency options, top pressure recovery turbines and coke dry quenching, again, there's no obvious core periphery acceleration effect. So if we want to get these technologies to scale, we can't rely necessarily on the early countries making all the mistakes, introducing it, paying the price of what Dan called, I think, first mover penalties, and then allowing later countries to come in behind and hoping that they'll do it more quickly, because there's not a lot of evidence that that actually happens. Direct reduced iron using hydrogen, how does that compare in the scenarios that have been put forward? How fast can we introduce it, for example, compared with continuous casting machines? And you can see that these two studies that Will has looked at, the Trans-Risk direct reduced iron scenarios and those by Morfeld et al., you can see that those do sort of match the experience with continuous casting from both the Netherlands in this orange S-curve and the EU in the red S-curve, and the global continuous casting here more or less matches the experience of the scenarios of Morfeld et al. So again, mixed evidence, but it looks at least feasible from that these scenarios could actually get these technologies in place in time. So just my final conclusions. Policy dynamics is important for environmental technologies, and late acceleration in some technologies is possible, but the evidence is mixed. That there is divergence among technologies, and we don't, I think, fully understand what it is that makes some technologies accelerate among later adopters than early adopters. It's useful to look at some of these historical analogues and to compare them with the kinds of scenarios that Silvia was talking about earlier, just to see whether the rates of diffusion which they're postulating for these new technologies are at least comparable to the rates of diffusion in the past. So thank you very much. And that's the website if you want to see more of the results from this project, which I think has been quite fruitful. So over to you, Michael, then, and we can take some questions.
Okay, thank you very much, Paul. And Silvia, that was a great overview of what I know are only a smidgen of the outputs from the overall INNOPATHS program, but are very, very interesting. We have about a quarter of an hour for Q&A before we'll move on to Lars to take us deeper into the steel technologies and scenarios. We've had one question on the chat, a comment also that I believe, Silvia, you picked up, and a second one just come in. So I'll ask those questions. I may throw in one myself, depending on the time and enthusiasm in the audience. But Paul, the first one for yourself. I guess it's a fairly obvious one, but it's what changes does Brexit make to the UK situation on industrial decarbonisation?
I think it's early to judge that, obviously. Things have still got to settle down. My expectation would be that Brexit will probably be negative on industrial decarbonisation. I mean, we found very clearly, as I think I said in the case studies, that being part of the EU was very important for certain countries. It enabled learning to happen much more quickly. It enabled governments that might not have taken initiatives by themselves. It enabled them to see what other countries were doing and sometimes with some nudging from the European Commission, actually to take those initiatives when they might not otherwise have done it. Being part of the science program is terribly important because so much of this research is done internationally. And while the UK is still part of the European research programs, I'm pleased to say we're not part of Erasmus anymore. It's been telling that even in the few months that we've been out of the EU, UK universities have dropped from being the #1 recipients of European research funding to being fifth now in the league table among European countries. So in my own work, where I work on policy, obviously everything in Europe is now geared to the European Green Deal. And it's very hard to see why other European countries would want to have the UK involved in that, because obviously we're not part of the policy processes that are part of the European Green Deal. So I have to say I struggle to see any positives at all in being out of the EU for these decarbonisation processes.
And the other question that's come in, I think for any of the panelists so far, potentially including Dan, Very interesting question. The emphasis on green public procurement, fully understood, but do you have thoughts on the actual metrics of that? For example, in relation to scope 3, embedded carbon, how one treats offsetting and insetting, which is a term I hadn't come across before, and how to construct associated tracing of carbon intensive materials. I don't know if Dan, would you like to pick that up possibly?
Yeah, happy to, Michael. And just say, I think Chris has just managed to summarize several very difficult issues in one very short question. So well done. I think, I mean, in broad terms, I think as I laid out in terms of the work that we're doing and planning to do, data, transparency, standards, certification is going to help on several of these fronts. And it'll be for the coalitions and the experts within our initiative to work on, you know, with standard setters to kind of figure out what the appropriate metrics are going to be and how to make sure that they get rolled out widely. So I think this is going to definitely be part of the work over the next 3 years. I have to say, from my kind of personal perspective, but I think this will very much be led by the co-leads of the initiative themselves. I tend to start with what's the art of the possible and then work from there. You know, these are pretty difficult issues to grapple with. So I think just starting, you know, getting something that you can really get your hands around in the first instance and then building out always feels like the practical approach. But it's definitely something that's going to be covered in our initiative over time. Thanks.
Okay, great. Silvia or Paul, do you want to add a bit on that? Anything?
No, I think that's pretty clear from me. Silvia may have something to say.
Yeah, no, I think it was a pretty comprehensive answer. What I can say is that, yeah, so just to expand on I think what we need to get to. So we spoke about the problem of this topic of industry decarbonization and the complexities of it, and I think that it was very clear in the presentation of Dan when he showed the slide with the images from chemical, steel, and cement decarbonization options, and how different they are. And I think that in this moment we are facing the problem of communication with industry stakeholders, but on the other side with policymakers. So I think this is really important because it's easy to communicate to policymakers, look, heat pumps in residential sector are so convenient, so energy efficient that there is no doubt about it, or electric vehicles in the transport sector. But when it comes to industry, we have to communicate a portfolio of options. And then we have the questions, what should we prioritize? Should we invest more on CCS? Should we focus more on energy-related emissions or on process emissions abatement? So it's very complex, and I think that we are at the stage, if we want to progress with this strategy, we are at the stage where we have to find a way to simplify the message for policymakers, give clear key points, make selection, prioritize options, because otherwise we can't expect policymakers to do that for us. We can expect, we have to be clear from our side, stakeholders or experts, researchers, whatever, to be clear on the message in order to then have clear steps to make in order to move towards industry decarbonization, because we are the sector a bit behind right now. So
okay.
I don't know if this answered the question, but yeah, it was just to add to the discussion.
Yeah. Okay. Now we've had one more question come in from Timo Geres. I'm going to mention it, but suggest we actually take it after the next speaker. But the question is, expresses a bit of puzzlement about the UK push to CCS when it seems, I quote, like globally the push is more towards direct iron reduction technologies. And there's a worry about whether that actually might take UK industry on the wrong track. I will actually park that for the moment, unless one of the panelists really wants to jump in, because I think Lars in the next session will cover a bit more of the specifics on steel, including the location of the UK industry. But don't worry, Timo, we won't forget that question. in the absence of others, I'm just going to mention one thing myself, and then we can move on to Lars. And of course, if people want to grab a quick coffee or anything, please do so now. Because I really just wanted to flag, see if any of the panelists so far want to jump in on the topic of electricity prices. This was emphasized, I think, by, well, actually many of the speakers, particularly Silvia and Paul. Paul in the context of the UK concerns relative to the continent, Silvia, Europe relative to the rest of the world. I think the fascinating thing about this topic is that normally in an industry, the economics work in favor of sweating assets. You've built something, you've paid for it to be built, it's cheaper than trying to build something new. And therefore, the challenge is the conditions of attracting new investment. In electricity, which Silvia focused on entirely, we're in a very odd and unusual situation where it seems the existing assets, or at least the existing system, the prices it's charging, are actually much higher, including the carbon price, than the new low carbon electricity technologies. And we saw the data on solar and wind, clearly cheaper. So we're in this strange situation, and it does raise a question about actually, given the scenarios that we have to have huge expansion of the electricity sector to meet the kind of electrification scenarios outlined, how come industry is paying a sort of a very large and sizably historic price, including a carbon price, when its future should really be reliant upon new investments, which would be a lot cheaper and don't emit carbon? This is an area that we're working a little on. We did a report with Aldersgate Group a few years ago about electricity prices. And I think that there's quite an interesting policy design issue that also speaks into procurement issues in the terms of procurement for clean energy. So I'm not going to try and answer my own question. We have some ideas, but with that, and sort of bang out a couple of minutes in advance of time, it's my pleasure to introduce Lars Nielsen. Lars is Head of Department and Professor at the Department of Technology and Society at Lund University in the Faculty of Engineering. So he's coming from an engineering and energy systems background. His recent research has focused on carbon transition policy and strategies and the governance thereof, but with a pretty diverse background, including times on the International Council of Wuppertal Institute, the Initiative for Climate Transparency, and more. And Lars and I have certainly had most interactions in the context that he is also a lead author, coordinating lead author for the industry chapter of the forthcoming IPCC 6th Assessment Report on Mitigation. So frankly, it's pretty hard to think of anyone better equipped than yourself, Lars, to give us an overview of the issues, options and scenarios in the steel sector. Over to you.
Thank you, Michael. I'm blushing. Thank you for inviting me. I got involved with the steel industry maybe 6 or 7 years ago for the first time, a bit by accident, being involved in a number of scenario workshops that they did, trying to figure out the role of steel in a sustainable future. Which I think is an important background for the later steps taken by the Swedish steel industry. And I will give a short background to steel and then provide more of a deep dive on hydrogen steel making. First, I'd like to echo what Dan Dorner talked about, the importance of thinking about demand, improving materials efficiency, improving recycling, with more circular material flows. Energy efficiency is always important, of course, but measures that can reduce the demand for primary production, because the primary production steps are the very energy intensive ones. But I will talk more about electrification, hydrogen, and CCU and CCS in this presentation. But let's not forget. And of those options, we do have long experience from energy efficiency in industry, relatively high recycling of steel already, although it can improve. But I think the materials efficiency and demand slowdown or demand moderation options are underexplored and underutilized. I would also like to give you a feel for what this is about. This is an old blast furnace in Russia. If you're interested in looking at more pictures, I really recommend the website by Viktor Macha, who has photographed hundreds of steel mills around the world. It's big units, it's noisy, it's hot. A blast furnace can produce 400 tons per hour. We have 57 of them across Europe. I have 5 here in the UK. I think Paul said 6. And really high emissions, 2 tons of CO2 per ton of steel. And what you do in a blast furnace is that you put your iron ore, pre-treated as iron oxide. You put it in there together with coal and coke, which produces a reducing atmosphere. And the whole idea is to strip the oxygen off the iron oxide and then get iron as hot metal that you see in this picture. If we think about the outlook for European steel production, this is a picture from one of our articles showing you production since 1990. You see the dip in 2008 with the economic crisis, but the current production about 157 million tons per year. Larger share of it is the primary route through the blast furnace and using basic oxygen furnace. 65 million tons in the secondary route with the electric arc furnace. And but the projection is that there will be a lower need for primary production as we can increase the share of recycled. So a future capacity need for primary production may only be 22 to up to 57 million tons. So it's not only that we have to replace blast furnaces or equip them with CCS, it's also that we need less primary production. So it's also about responsibly phasing out the blast furnaces. And here's one example from Germany, ArcelorMittal blast furnace, and you can see the size of this thing if you compare to the building, which is down to the left side of this picture. Now, the options for decarbonizing steel, Eurofer, the European Steel Association in Brussels, talks about 2 main routes, or 3. It's the circular economy, which we will hear more about later. But for the primary production, it's called smart carbon usage and carbon direct avoidance. And with smart carbon usage, it involves both CCS and CCU. But it's important to point out that CCU, taking blast furnace gases and turning them into chemicals or fuels or whatever, actually doesn't lead to zero emissions. It only shifts the carbon emissions to somewhere else. And with CCS, it's also difficult to get to zero because we have limited capture rates, especially if we go into existing plants where not all the emissions comes in one stream. You can potentially have zero emissions with CCS if you build new and use the so-called Hisarna technology, but even then you would have to use 20 to 30% biocoal to get to zero, because you have to compensate for some of the CO2 that you cannot capture. And the latest I heard, Tata Steel is now planning for an upscale of the Hisarna process in the Netherlands and connecting it to carbon dioxide storage, but no plans yet for having biocoal involved. Instead, I would like to shift and turn the attention to the idea of hydrogen steel making or electricity. Hydrogen reduction is one option. Electrolytic processes with electricity is also a possibility for the future, so-called cider wind, but it's at a much lower technology readiness level. And it was interesting. It was an interesting shift, a real change in 2016 when the CEOs of the Swedish companies, the mining company LKAB, the power company Vattenfall, and the steel company SSAB joined forces and wrote this article in a Swedish business paper. You see it's pink, and explaining this is how the steel industry can become fossil free, and sort of broke ranks with the rest of the European steel industry, who said there was no alternative to CCS. These guys came out and explained how hydrogen was an option. And today, since last year, we have this pilot plant up in northern Sweden producing 1 ton per hour. And only in May this year, they have produced for the first time with 100% hydrogen direct reduction iron sponge in this plant. An interesting fun fact here is perhaps that the CTO of the steel company did research on hydrogen steel making already in the late 1980s at the Royal Institute of Technology. So perhaps that's where the seed was planted to do hydrogen reduction. The hybrid project has also accelerated the plans to scale this up and moved it forward by 6, 7, or 8 years. So now the plan is to produce 1.35 million tons per year direct reduced iron using a 500 megawatt electrolyzer and using 5 terawatt hours of fossil-free electricity. And this means that they will put fossil-free steel on the market in 2026. So things are moving ahead fairly quickly now. We also see an increasing interest from steel users, especially the car industry, where Hybrid has an agreement with Volvo as cars become electric. So for example, a Polestar Volvo all-electric battery car, if it uses clean electricity, it has 0 emissions. But that car company is now worried about the embodied emissions, because the embodied emissions through the materials in the cars are equivalent to 26 tons per CO2, and they want to reduce that to 0 by 2030. So attention is really shifting to the embodied emissions in materials. We also have seen that the Swedish hybrid project has been followed by another announcement, a greenfield hydrogen steel mill called H2 Green Steel in Sweden, where Mercedes-Benz has taken an equity stake. And also Scania, the truck maker, gets involved with a stake in the H2 Green Steel. And this is interesting developments, strategic reorientations. When we asked Scania 5 years ago whether they would be prepared to pay a premium price for green steel, they said, no, we won't do that. And then 2 years ago, their CEO stood up and said, yes, we will buy green steel. And now they get engaged also in the production. So even if Hybrid was the first project announced, it has since been followed by several other projects. German, Austrian, Vestalpine, Salzgitter, ArcelorMittal, even the Chinese and Japanese companies are now taking an interest and moving in this direction. And if you are interested and want to look more closely, there's a database called the Green Steel Tracker at the webpage of the Leadership Group for Industry Transition, and you have the link down here. So to sum it up, potentially a very large electricity demand needed for converting or shifting the current steel production in Sweden. It would need 15 terawatt hours roughly. If we go for processing all the ore that is produced in Sweden with hydrogen reduction, we would need around 60 terawatt hours. For Europe, it means about 400 terawatt hours to convert everything to hydrogen. So again, it underlines the importance of material efficiency and recycling. But it also means that we might need to think about potential relocation of industry, that future industry, energy-intensive industries, including iron and steel, may relocate to renewable resource endowed regions where you have access to, for example, cheap offshore wind, as perhaps could be the case in the UK. Another observation about this, and this cuts across also to other industrial subsectors, is that we're seeing these new value chains, new collaborations, and sectoral couplings. And I think an important reason for hybrid is that it has 3 companies, all headquartered in Sweden, with CEOs in Stockholm that can easily talk to each other and agree on what to do. So that has also been part of that. And if you look at this new value chain with hydrogen steel making, you go from electricity, renewable electricity, from wind, maybe in hydro, you do make hydrogen, you produce the iron sponge, and you then make it into steel. And it's not clear from the outset how these 3 companies sort of split up that value chain and how they will share all the risks and benefits of this. It involves increased production costs. It seems like in car making, premium car makers are prepared to pay that extra cost. But basically what you need is a carbon price of around 60 to 70 euro per ton for break even under the Swedish conditions with relatively low electricity prices. And there is a need for government support here. Industry, of course, wants inexpensive and clean electricity. Simpler permit procedures, both to expand renewable electricity production, but also to be able to build their plants, and also get some risk sharing and government support. And one option for doing that, of course, is carbon contracts for difference, which could be a good way of de-risking these investments. And of course, together with the procurement of green steel and all that we have talked about. And maybe on this note, Michael, coming back to your point about electricity, I think one development that we will see is stronger couplings and collaborations between energy-intensive industries and electricity production through power purchase agreements or direct ownerships, as we saw, I think, last week or 2 weeks ago, the chemical company BASF announcing that they buy a 49% share of a big offshore wind park and enter a power purchase agreement for, I think, the whole production of that wind park. So that concludes my presentation, and I hope that allows us also some time for questions. You're mute.
Thank you very much indeed, Lars. That was very interesting, and congratulations also to Sweden on those initiatives. Before we move to Q&A, we have 2 panelists and a respondent. So I'd like to move through those and then open up for questions and answers. So the first panelist, clearly a view from Brussels at this time would be interesting. I'm delighted that we've got Milan Ekins. He's a research fellow at the Centre for European Policy Studies, the Energy, Resources and Climate team. Milan focuses on EU climate policy, European emissions trading system, carbon pricing and industrial transformation. I believe the Commission package is supposed to be officially launched in less than 1 week, but has already been fairly widely leaked. So Milan, we look forward to hearing your own news and views on developments in the EU.
Yes, thank you very much, Michael. And indeed, we're less than a week away, although some of the leaks have definitely changed between the different iterations. So there might be yet more surprises next week. So before I get to the EU policy options, I quickly want to go through some of the main conclusions which we went through in a project called Green Steel. This was a Horizon-like project for DDA research. And we also focused, sort of in line with many of the other presentations we heard today, on 6 policy areas: scraps, renewables for both direct and indirect electrification, so therefore green hydrogen as well, CCUS, carbon pricing, and more horizontally funding. And then we tried to, we had a lot of consultation with the steel sector, representatives outside in civil society and academia. And when we asked for policy solutions in each of these 6 different areas, there were a few that kept coming up again and again. And I think most of them we already heard today. But it's clear that things like carbon contracts for differences to bridge the gap between the ETS price and what you would expect to be the initial costs of green steel investments. They were definitely very popular. Same with green public procurement, labeling, and then on top of that, we also discussed, well, what happens actually with the ETS reform. People in general were skeptical about the contribution that the ETS could make to decarbonize steelmaking, but on the other hand, it's definitely going to happen. So we might as well look at the impact of it, especially also with the other carbon pricing elements, such as the CBAM. And then finally, embedded carbon standards, sort of an alternative to carbon pricing, were also considered quite promising, although they are not necessarily popular within the industry. But as a powerful policy option, they are definitely worth considering. Also because it can, in a way, also act as a carbon leakage mitigation instrument once you actually have green steel on the market. So maybe to go a little bit into 3 policy options that we might see next week. The first then would be the carbon border adjustment mechanism. It's very controversial for a few reasons, some of which have been addressed or at least answered in the leaks and will probably show up in the proposal. But one controversial element is what you actually do with exports, because you, that's an important part of the market and of industrial competitiveness as well. And the carbon border adjustment mechanism only deals with imports. There's no real answer to that yet, but it might still play a role in the eventual design. Second is whether you have the mechanism applied to intermediate goods or final goods as well. Ideally, it would be very comprehensive, therefore also targeted to all final goods using steel. That sort of makes the complexity even larger than it already is. So for now, we have intermediate goods. And then indirect carbon costs. So from the higher electricity prices, they are actually being tackled in the proposal. And for that reason, aluminium might also be covered by the mechanism. Finally, very controversially, what happens to free allocation? The Commission has always maintained that the CBAM is an alternative to free allocation, but this is proving to be a very difficult political hurdle. It might be the case that you combine the two mechanisms, and it is indeed true that you can do that, because if you still have a little bit of free allocation, you can simply reduce the levy of the carbon border adjustment that's levied. But nevertheless, in sort of political perception, it still feels like double protection, and this might create some difficulties with the climate diplomacy. Then on the ETS reform, I would just like to highlight one element. If we are still going to have free allocation in the future, what for steel is very important is that the product benchmarks that determine the free allocation volumes are updated, because right now we have 6 different product benchmarks for EAF steel, for hot metal, for the coking part, etc. And what you want is substitution between the two, because we don't necessarily need every part of old steelmaking processes to be updated. We just need to have efficient, competitive green steel. So for that reason, you might need to start thinking about aggregates of these product benchmarks. And the same thing happens in other industries, because otherwise you might have a situation where the Swedish low carbon steel makers actually receive fewer free allowances than the traditional steel makers, which is not a desirable outcome. And finally, a little bit on the carbon contracts for differences. They are a very powerful potential mechanism. But maybe one thing to keep in mind is that you can make an analogy to the role of hydrogen in industrial decarbonization. They are more a carrier of funding than a source of funding. And you also see that in the European debate now. The carbon contracts for differences are being proposed under the ETS reform as a way to distribute the money from the ETS Innovation Fund, which is a great idea because it's a good mechanism. But if you don't change the size of the ETS Innovation Fund, then the impact might still be limited. So in addition to making sure that the mechanism as such exists, it will also be important that there is enough money, whether at EU level or at member state level, that can ensure that you have enough CCFDs. And then finally, maybe one answer to that is if you look at free allocation, you have a tremendous financial asset, which with the increased carbon prices we are seeing today, 50 to 60 euros per ton, and the volume which we might have up to 2030, 2040, even with a minus 55% target, you are still looking at 20 to 30 billion euros in free allocation every year. It gets a bit less after 2035, but it's a tremendous asset. So if we want to do efficient industrial decarbonization using these, making sure that this money, whether through allowances or by monetizing the allowances, ends up where they have the most impact on transformational investments, will be really important. So thank you very much, and back to you, Michael.
Okay, thank you very much. And clearly a rapid debate going on in Brussels around the options, which is where we need to happen. And finally, I want to hand on, or not finally, because we'll ask Silvia to come back as a respondent in a moment. But first, Matthew Winning from our own research institute at ISR. Matthew's involved in a new project on the circular economy in steel, and has a rich and broad background in many aspects. Matthew, over to you to offer your thoughts, particularly around the circular economy side of it.
Thanks, Michael. Yeah, so I mean, I think all the points that have been raised today have been really interesting, and of course, the focus on new technologies is extremely absolutely essential in meeting the increased demand. But there's still, I guess, I think requires to be a focus on the current recycling of steel using electric arc furnace, and how that's going to kind of play out on a country by country basis over the coming few decades. It's obviously, as Silvia talked about earlier, a much more established technology, and therefore trying to utilize that to as great an extent as possible makes sense in the short term. So the UK currently only uses about something like 2.3 megatons of scrap a year, and exports something like, I think, as Paul said earlier on, closer to 9 megatons of scrap a year. But also the UK's capacity could use about 2.5 times. So as I say, it's about 2.3 tons. It could use about 2.5 times that within its current capacity of scrap, but it's currently underutilized. And a lot of that is to do with the issues around electricity prices and areas like that. So there's quite easy wins there, where you have a massive supply of domestic scrap and an underutilization of scrap in current capacity for production. A lot of the issues come down to contamination and purity issues. So really kind of getting down to supply chains of scrap in different sectors. So obviously you have home scrap that's produced in the iron production. You have sort of prompt scrap, which is produced within, say, car manufacturers and those sorts of processes. And then you have end-of-life scrap, post-consumer scrap, that happens a lot later. And it has a lot, a large potential there. So, I mean, from an expectation of demand increase and that sort of thing, I mean, so China, as we alluded to earlier, produces about just over half of the UK's current steel production, but China only uses, I think, around 10% is electric arc produced. The IEA's, I think, stated policy scenario even has that pretty much across the board, has the amount of scrap through electric arc produced by China increasing to about somewhere around 50% by 2050. So there's massive increases in this area that's going to happen over the coming years, that in tandem with, you know, probably production through direct reduced iron from hydrogen are going to be able to meet demand. But I think there's some short-term kind of easy wins that we can talk about. One issue that's come up a couple of times in the UK recently is the lack of price difference between the high grades or high purity steel, recycled steel, versus low purity recycled steel. So there isn't a huge amount of price differential there. So there's not much of an incentive for sorters to actually invest in the types of technologies, you know, more advanced techniques that could sort out scrap better into higher quality grades. And having some sort of product specification or product standards on the quality of scrap would also be a really good short-term improvement. At the moment, a lot of it's done by eye. Essentially, people go around and say, have a look at some scrap and say, well, roughly that looks okay, but there's, you know, is that the way that we should be basing our low carbon steel on? So yeah, the discussions earlier on about product standards for low carbon steel, I think, need to apply for both the production via new technologies and new techniques such as from hydrogen, but they also need to be applied much earlier in the stage for electric arc from scrap as well. So yeah, I'll leave that there. I mean, there's the question as well, which I think was brought up by Lars, about changes in material efficiency. There's lots of areas that can, extending lifetimes of things, reusing scrap, like directly reusing rather than it being recycled. These things can reduce the amount of scrap that's coming on, but basically we're going to have an increase of scrap availability pretty much across the world over the coming few decades, but we've also got an increased demand that we're trying to meet as well. So yeah, I think it's just a call essentially to not forget about the technologies and the processes that we already have there that are low carbon and becoming even more low carbon as obviously the electricity sector decarbonizes, and making, arranging policy to make some really good low carbon decisions in the short term in relation to the circular economy, I think are possible as well. So I'll leave that there.
Thank you very much. Let me just inject one comment and then hand over to Silvia, partly to bring us back perhaps to a cross-industry view. But I just wanted to almost draw, suggest, test an analogy. In the decarbonisation of the electricity sector that we've seen in the UK, there's a sort of easy tale that, oh, it was about the fantastic progress in renewables, and that displaced coal. Actually, when you look at it, what's happened is much more interesting and integrated. It's been crucial that actually we managed electricity demand. We increased the efficiency of electricity demand, which actually started declining for the first time ever over the last 10 to 15 years. And you had a carbon price which initially drove a transition from coal to natural gas. Now, analogies are never perfect, but the point is that what then happened is when the renewables increased in scale, there was nowhere left for the coal to go. It was simply no longer needed because the pressures had contained both the demand and switched the supplies. And I do wonder in the steel sector if there is an analogy, imperfect, that efficient use of steel and maybe direct reuse is something that contains the demand, along obviously with recycling, and it's going into electric arc, almost playing a little bit a role of gas, as in a lower carbon fuel, which in principle could be certainly lower emissions, but on which we seem to have in this case perverse incentives, and that helps to buy time and for the growth of the hydrogen-based steel, and that combination really narrowing much more rapidly the need for blast furnace steel. Now, like I say, it's not perfect, but I think it's very important in this area that we think about the combination of the kind of things that Matthew's talked about, and that Lars at one end with what Lars has talked about at the other, and how those will in a combined way bear upon the steel markets and the different technologies. So I don't know, Silvia, if you would like to make any comment on that or other aspects of cross-industry interactions, of which I'll just flag one, which is some of our researchers that one of the major cement options is using slag from blast furnaces. So if we get rid of blast furnaces, that will have spillover implications for cement. So any reflections also on those cross-industry linkages that you might like to inject, and then we'll open up for the Q&A. But Silvia.
Yep, exactly. Yeah, I agree. So first of all, I agree on this, on what Matthew said, that basically there is not, also for steel industry, there is not going to be one single solution, which is reducing steel demand and then applying secondary steel, but it's going to be a combination of solutions. So of course, secondary steel is a fully developed technology, and if we implement, if we manage to create an integrated steel loop, steel cycle, then we can improve the production of secondary steel while we fully develop the direct reduction of iron with hydrogen. But the two options would be needed. Sure. And in terms of the implications that intrasectoral implications, of course, not only the intersectoral implication between, for example, cement and steel, so reuse of blast in cement can help reduce emissions, but also the implications that we have in material demand from, for example, the transport sector. Reducing production of cars can reduce the demand of steel, can reduce the emissions that we have related to steel. So all this materials demand reduction is very important. It's now, I think, under the radar. It's circular economy is certainly one of the fundamental components. So decarbonization. So yes, and in terms of other intersectoral implications, yeah, I'm thinking, well, for sure the reuse of blast furnaces in cement, but we could, there is also another important aspect, which is the integration of CCU with the chemical industry. So if we capture CO2 from cement and steel, can this CO2 be reused to synthesize some hydrocarbons that go into the chemical sector, for example? Will we be able to do that? Or if we invest in CCU, which is, I think, something where the cement industry is going, what will we do with those products? Where will those products go? So will they be consumed in the industry, in the cement industry itself, or will they be shipped to different sectors? And how will we integrate this? And I think there is a very interesting concept that is developing now, which is this concept of smart industries. So not only smart cities, but smart industries. So industrial poles where you have multiple production sites, not necessarily only cement, but cement, steel, multiple production sites all together, where there is a sharing of waste heat, circular energy also reuse. So these concepts, I think, are very important when we talk about decarbonization of industry.
Right. Okay, thank you very much indeed. So that brings us to the end of the formal parts of presentations and panel. I'd like to pick up, we now move to the Q&A, so do feel free to send in questions on the Q&A function. But I would like, as promised, to return to the question that Timo Geris raised, which was focused around, given the success of the electric arcs, he's a bit puzzled about the UK push to carbon capture and storage. And it seems like globally the push is more towards DRI, hydrogen-based. And is there a risk the UK push to CCS might lead to an industry that's, to his words, even less competitive to green global competition in the long run, and would end up relying on public support? So a bit of a challenge to an aspect of the UK strategy there. I wondered if any of the presenters or panelists would like to pick that up.
I'm happy to briefly state that. I mean, I think it's an excellent point. As far as I can tell, it's very unclear at the moment whether there is any commitment to either route in the UK. So I know that British Steel has committed to being part of a low carbon cluster and has mentioned carbon capture, but hasn't committed, as far as I can tell, committed to that is exactly what we're going to do on our site. So, you know, you have two sites in the UK, and they both are close to, both close to the ocean, and access to the North Sea, especially for the British Steel site, is probably a bit more difficult for the site in Wales to access oil and gas fields. So I think the UK emphasis has been on carbon capture a little bit just because of the potential for storage in the UK compared to other places. But I think that the exact point that you make about competitiveness issues, if the UK goes down one route and everywhere else goes down another route, is entirely valid, and in my opinion will mean there will probably be a last minute switch in a couple of years' time where the UK decides, no, we're going to do hydrogen, and then move to that, but it will be a year or two after everyone else does it. So that's my, I mean, not expert opinion, but just given having lived here for a long time, it's probably what will happen.
Any other panelists want to come in on that?
I think it also links back to the question about what is green steel, you know, that we need metrics, etc. And will CCS steel be perceived as green and defined as green under whatever standard you might have. If I were a car maker, I would prefer hydrogen steel to CCS steel. But there's a lot of issues around this. What will count as green, and what is it that you want to achieve? Do you want to achieve 60-70% emission reductions or 100% emission reductions? Do you want to support increased recycling, so labeling recycled steel as green? And in all those contexts, we have to be very careful about creative bookkeeping, so to speak, from the side of the steel industry. So, for example, using blast furnace gas to produce, carbon to chemicals, where you put the responsibility for carbon on someone else, or suggestions like allocating some of the carbon emissions to recycled steel has also been proposed. So we have to be careful about what we label as green and how we do the metrics.
Yeah. Okay, and I'd like to raise a question also to Milan on the chat, on the Q&A, which I suspect will become a bigger and bigger question over the coming year, which is what will happen to the revenue from the carbon border adjustment mechanism? And could it be invested in low carbon steel, low carbon technology specifically, steel, R&D, demo? You referred briefly to possibly funding the carbon contracts for difference as well. Anything else we know about the potential revenue dimensions? To which I would have to say, I think other countries may have something to say about what they'd like to see happening to revenue, particularly from poorer materials exported from poorer countries to Europe. Over to you.
Yes. No, it's indeed a very good question, and it will be hotly debated for sure. CBAM revenues, insofar as they will exist, are a bit like the ETS auction revenues. They are always oversubscribed. Many people can find good ways to spend it, and treasuries usually have first dibs. With the revenues from the border adjustment specifically, I would think we indeed need to look also really beyond the EU's borders. Right now in the leaked proposals, there are no real suggestions that it should be used for, say, international climate finance or even supporting technology transfers. But if you think about the climate diplomacy side of the CBAM, then making the money flow back to member states' coffers is not really going to dispel fears that it's really more about protectionism, and even if you can have a legitimate argument about mitigating carbon leakage risk. So it would be good as well to spend it on things like industrial decarbonization, CCFDs. But my first option would be to at least have a decent chunk of it also benefiting climate policy outside the EU's borders, just to make the mechanism as such acceptable. And they're also not that large, especially if you consider that there might still be continued free allocation, limited application for sectors. It's a few billion every year, which is not negligible, of course, but if you compare it to the ETS auction revenues, they are a lot larger. Then maybe if I could...
I want to pick up the next question as well. We have one just for the audience. Joe Biden said a CBAM, which I guess is an acronym most of the audience now will recognize as the Border Carbon Adjustment Mechanism. Joe Biden said it should be the last resort for Europe to go down that route. What do the panel see as alternate trade competitiveness avenues that could deliver cost competition for low carbon steel, given that they are likely to remain more expensive? Could standards or moratoria be an alternative? Maybe Milan first.
So the alternatives to carbon border adjustments. I do think the idea of standards could be very powerful. Also, to mitigate carbon leakage risk. The thing with standards is that it will do nothing really for industrial competitiveness. in the EU, which is, they're often treated the same, but they are different things. And with standards, you're really only mitigating the carbon leakage risk. I've also discussed this a bit with sort of trade experts and within CEPS, and they get very nervous. They almost gave me a bollocking for even daring to call it standards, because they have a very specific definition in the under the WTO, and they were not convinced that something like the equivalent of a vehicle standard that already exists could easily be applied to such a massively traded good. Probably the same type of exemptions that would allow the carbon border adjustments to be legal might also be applied there, but it would also require very careful design. It's not something you can just pass as a domestic measure and then think no one will challenge it.
Yeah. And sorry, I should have said that was a question from Robert Campbell Davis. I don't know if other panelists want to pick up that question. We have one more that's come in, so if no one's jumping. Just to saying so Simon Ellis is flagging the IEA cited a theoretical 15-folding hydrogen demand from steel globally if we're moving to DRI, electric arc. And are there constraints on the potential share of hydrogen in Europe on both process and competing technology perspectives? Perhaps one for Lars or Silvia?
Well, it seems like one of the biggest challenges now is producing enough hydrogen and getting the hydrogen to where the steel plants are, or relocate. But I wouldn't say that you know, there's any real limits to this.
Yeah. Silvia?
Yeah, I agree. There is no limit, but it's going to be interesting how hydrogen will compete. So the hydrogen demand will compete across, you know, steel sector, chemical sector, storage. Yeah, there are. So now there is this hype on hydrogen, and everyone wants to use hydrogen for everything. We'll have to decide where hydrogen will go first. I think steel is a good candidate because we saw that there are not so many options, and hydrogen is a good candidate to decarbonize steel. So we have the know-how already. There are demonstration plants already built. So it's. I think steel is going to be a first candidate to use hydrogen in a good manner, because it's not that we have so many other alternatives. We have some alternatives, but they have their own limitations. So
Maybe I'll also just reinforce that without giving kind of any secrets away in the IPCC process. I think hydrogen is beginning to take the same characteristics of biomass energy, which is, it's infernally complicated. It involves lots of different sectors, all wanting a slice of it, but clearly a limited resource, and some challenges around transport and tracing. Because of course, at present, we do produce quite a lot of hydrogen and we emit enormous amounts of CO2 in producing it. So, you know, it's a vector and we need to trace it back to the adequate production of clean sources to make the hydrogen. So that is going to be, I suspect, a major area of research for any of those listening who are looking for interesting topics for the next couple of decades. I think the hydrogen economy in its many ways of generating transport and use will be a very big thing. I don't see more Q&A coming in. In principle, we have a few more minutes left, but I actually think we've covered the main ground there. Tim's come back, actually, Tim Milgeres, sorry. Do you want to just ask one last question, and then I think we can draw the meeting to a close. So Timo has asked, why not relocating industrial plants to where the green hydrogen is likely to be cheapest? I like that, brackets from Madrid. So, part of the idea of some of the policy tools we've talked about is how can we keep industry? And if the answer is hydrogen is a way to keep it clean and green, but actually maybe it should anyway to where there is cheap, clean and green hydrogen, that will pose some interesting political issues as well. Does the audience like to come on to that? Sorry, did the panel like to pick up that one?
It's a good question from Timo, and there are interesting things going on, for example, in Australia, where you have both the iron ore and you have excellent renewable resources through wind and solar in Western Australia. It's certainly possible that these primary conversion steps do locate in regions that have the resources. So, for example, much of the German industry in the Ruhr area, they are in the wrong location, you could say. They located once in a time close to coal resources, right? Close to energy. Now they're in the wrong place.
Yeah. Any others want to come in on that locational issue? And then Teresa Dominic has raised a question in the Q&A as well.
No, I was just going to say, I think Lars' point's extremely important, and it differs here because, it's where the electricity is, and it's it's something that we're not, you can't trade globally, and it comes back to why electricity is different from other inputs into production, and so the question of locating in specific places becomes more of a necessity or more sensible approach, I think, here.
Okay, and just to raise Teresa's question, it's really asking that the pull from demand is actually growing quite rapidly, not just from automotive, which have been mentioned, but also buildings and infrastructures. And Teresa's suggesting the transition is likely to be fast, but is there enough policy certainty coming from the EU and elsewhere? It's been mentioned in the panelists, but mostly in terms of specific technologies. How about the maturity and clarity of policy to help support a fast transition? And Teresa also flagging probably the big issue is how China, India will move, and how do you see the international situation as well as EU on those questions? Maybe Milan first.
With things like policy and regulatory stability, I always understand why it's very desirable, but if you just look at all the initiatives that are being undertaken under the Green Deal, there's an annex of legislative and regulatory proposals of 3 pages long for the next few years. How realistic is it within the type of governance polity that we have in the EU, even within a single member state? So I think with things like state aid rules, you can at least streamline it and create stability at the member state level. But it's inevitable that some of the things will change. Nevertheless, with the uptick in demand, that can only be a good thing and make it easier for policymakers.
I think there's a lot of uncertainty around policy. So if you put yourself in the shoes of investing in a greenfield hydrogen steel plant, a lot of policy uncertainty, but I also think a lot of confidence because there's clear directionality, there are clear signals that this is the way to go. And so I think the investors are confident that there will be policy that can help them along.
Silvia, do you want to add on the international side, perhaps? If not.
Yeah, just to say that I mean what I also mentioned before, that there must be more common efforts on this topic on the industry decarbonization, and of course it's very complicated because industry is so connected to the economy, to the competitiveness of in the market of different products and coming from different countries. So it's quite complicated, but. It is important. I think Europe is leading a bit the way in this in the policy making in general on the energy transition, but in an industry like steel, we will. It's going to be very important that the international market is going to be fundamental. So the role of China, India, and I think also Australia, because we will, in terms of, I think Australia can bring a big change in terms of, the capability to produce hydrogen and to have the iron ores. So there will be important decision to be made there, but not more to add than what the other panelists said.
And China will be interesting to watch, of course, because they have a huge overcapacity and will go through a shift towards secondary steel making, with scrap based. So huge overcapacity in blast furnaces.
Also, Japan and South Korea have made announcements that would really be compatible with or the steel makers in these countries with climate neutrality. So ultimately, if EU producers don't cannibalize their own old assets and invest in new, then someone else will.
Yeah, exactly. One thing I want to add is that exactly this. So of course, the steel industry, the crisis that we saw in the steel industry in Europe, has triggered the interest of the European steel industry to invest in green technologies. So to acquire the know-how that can give the leverage on the market, because once you label your steel, the first green steel produced in the world, we have developed this technology, we have this demonstration plant, this gives you some leverage on the market against a competitor like China, which has all the quantity, and you can never compete in terms of quantity. And I think it's important for many industries, in small companies producing steel, to acquire the know-how that first, to acquire the technological knowledge that then can export. It's going to be an interesting,
Okay. Well, let me draw this to a close with just a couple of remarks from myself on that, the last questions on international. Because as we saw from the statistics earlier, this is very much an international challenge in terms of emissions, competitiveness, value, lots of other things. There certainly are interesting developments touched on. India, a very interesting role as co-lead also on the IDI program of the Clean Energy Ministerial. We think back to Dan's presentation. China actually was the first place that I heard the term urban mining to try and extract some of the huge quantities of materials, including bringing down some of their older buildings in their rush. I wouldn't forget South Africa and Brazil as major players in several of these industries, and certainly they're thinking about the supply chain and whether or not demand for green materials, perhaps in Europe, they could try and find competitive advantage in. But I think the key question then comes back at the international level as to what kind of governance and architectures might help. It's really been quite striking. The history of the UNFCCC process has been very much an intergovernmental process, very reluctant to get involved in the details of how anything would be implemented, very little direct engagement with industry in terms of how might one transform the sectors at stake. Where there has been sectoral progress, inadequate, but nevertheless progress, has been where there was a clear devolution of responsibility to ICAO and its global emissions cap, and IMO, where there are many interesting political tales. So I guess one question is whether or not the international system is capable of actually formulating a global approach to the transformation of the steel sector. Of course, it's very different. There's no pre-established governance structure. It's absolutely screaming by its absence that there are no mechanisms for governments to help drive a sectoral transformation in most of these industries. But of course, there are a collection of multinational companies, many of whom don't care very much where exactly things happen, because their value comes from wherever it is most cost effective to run their production businesses. And that will be another dimension I think we will need to increasingly bring into the conversations. So I just thought, having started at the high level with the Clean Energy Ministerial, and then drilled down through European and UK policy, it's great, Teresa, you brought us back to thinking about the global level. And I think there, as well as in Europe, we'll find we're still having these conversations and challenges for quite a while to come. But clearly there is movement, much more than a few years ago. So it's a really exciting area to be in. So on that note, I'd really like to thank Harry Barton and Ella, who helped to organize this meeting, Paul Ekins and the INNOPATHS program for helping support it and push it forward. And of course, to all the speakers and the panelists on that session, as well as yourselves in the audience. This brings us to close, bang on time. Thank you very, very much for everyone helping to put this together and participating and listening. And the presentations, subject to speaker agreement, will be online shortly. So thank you very much. And good morning to all of you.
Thank you.
Thank you.
Bye.
Thanks a lot.
Cheers.